Trustworthy AI. If we talk about AI in a general sense, then there's always a discussion coming up about ethics and are those algorithms cheating or biasing or etc. So in the bank, that's also an issue. Can we use an algorithm to predict or to grant a loan, yes or no? And do we then bias on gender or age or whatever social status? As something we do not want. I'm involved with a lot of projects on that, and it's a lot of discussion groups on that. And I thought perhaps let's shed some light on that trustworthy AI. I'm part of a thinking team, a thinking group on human, we call it Human and Tech Institute, where we provide some guidelines towards what is ethic and what is not. Again, I work for Rabobank Business University and Nyenrode and Rio. To start off, why is it the problem? Why is it the problem? Artificial intelligence is going to be everywhere, and we need to see if machine learning is taking it too far. Can we just join in every conversation like Siri does? And what about the decisions that come out of the machine learning? Is that proportional? Is the data that is used for the decision, is that biased? Is that discriminating? And lately, a friend of mine said, yeah, but the algorithms are needed to discriminate. Yes, but not on the wrong courses. So that's a little bit what we're looking into this. And if you look at artificial intelligence and ethics, this is a word cloud I created with BigML for the Human and Tech Institute made a moral compass in 2020. And these are the words that come out. So systems, AI, values, people. There are a lot of words, a lot of buzzwords, but a lot of words in there. And I was confronted with an AI ethical framework of over 50 to 80 pages. The EU Ethics Guidelines for Trustworthy AI published a nice paper. It's really good to read, but it's over 50 pages. And I already see my internal IT department providing me a checklist of all the things I need to consider before even thinking of making an AI. And that checklist will then become the mother of all truths. And I have to fill in if my AI will impact the world climate, etc. Yes, that's true. You need to think about it. But is it the good question to ask a software engineer or an AI engineer or a decision engineer, like I call it, on the ethicalness of the AI? And I was totally, because I had to review a 100-pager again with all kinds of considerations that could be. I thought, okay, there must be another way. And of course, these 7 aspects of accountability, transparency, privacy, technical robustness, those are all true. But if you dissect those and you come to checklists of hundreds of questions or considerations, and those are being asked towards the decision engineer, that felt a little bit wrong. So I started thinking on what is now trustworthy AI and how can I assess that, and how can I make sure that what comes out of my assessment is technically applicable, but also, hey, can I create trustworthy and ethic AI? Why do we need it? Yeah, we need it because everybody's fooling around with my data. Searches in Google are being biased because Google wants my advertisements. So the searches are being used to bias the results I get. Do I want that? I don't think so. Um, what is the discrimination that's going on, and what's the unfairness that's going on? That will be about gender. That will be about giving up all your data, etc., etc., etc. If I assess a customer, do I do it on a fair way? This is a nice illustration of that issue. And now, what is fairness? Then I started to thinking on BigML, because I use BigML. So I have a platform that is transparent, explainable, auditable, robust, and repeatable. But still, there is the question of, is it an ethic? Is it ethical what you're doing? And that remains the question. So then I started thinking on, okay, if you have that Bible of 100 pages with all kind of questions you need to ask yourself, is there another way of looking at ethics that is more pragmatic? I'm a pragmatic guy, and more not of there is an absolute moral standard or an absolute truth to which I can assess the things I'm doing. So I said, now perhaps we have to look at it situationally. So situational ethics should be could be a nice angle to do that. And then it comes a little bit more towards my comfort zone. So there is not a biblical law, an absolute moral standard, but I have a situational approach to ethics that is into my project. And then my favorite philosophers come in, Sartre, Beauvoir, Jaspers, and Heidegger. Okay, yeah, now can I think again. So there is not one golden standard of which, with all the questions being thinked of like a checklist, then I'm ethical. No, that's not the case. There is another aspect to ethics that cannot be captured into a checklist. That's where I come from. So I come from, hey, it's a lot. We need to do things. There is a lot of things written. It tends to be a checklist, and I don't want to be there. So situational ethics, bear with me. Then you know this, if you're a little bit familiar to BigML, you know this. This is where to start. Let's predict milk production. That's something we do in Rabobank for our agriculture. That is what a farmer could ask. What is step 2? I said, hey, Mark, now okay, this starts with the question. Great philosophers always start with a good question. So I started, hey, what is missing in this CRISP diagram? What is missing? What is missing here is the ethics. And we try to derive the ethics from the implementation of a machine learning model or an AI. And I thought that's totally wrong. That's totally wrong. Because if I'm already at the model phase and at the model, then I'm much too late, because perhaps the question is not moral. And if the question is not moral, then how can my model be moral or ethic? Yeah. So I started thinking on the ethics of the question. Then I came to the following mind map, and bear with me, this is not what you have to read now, but I drilled it down to let's say, a step that I can use in my reality. Because if you look at the CRISP approach, you start off with the business understanding. Now let's start with the business initiation and the business question. Then I do model creation, model use, and then I said, okay, we need 2 aspects too, destruction and reuse. Because if I'm going to make an AI model for my business, then it will be aligned with the above. There's a business question, there's a business need, business initiation, there's a question, there's a model, as a model use. And if I'm fed up with the model, I have to destruct it, or I deliberately have to reuse it. And I think in that framework, you could be working towards ethical models. So I have dissected this a little bit more into, okay, what is the aspect of business initiation? This is the way I think you should do it. Do you have as a business an ethical framework? That's the first question. So not is the AI ethical, but does your business have an ethical framework? If I do a AI for weapons industry, and I do not think that the weapons industry in itself is ethical, then no model that is in there could be, you need an ethical framework to assess models in weapons systems. And I think the business should own it, not the AI guy. So what is the business need, and what are the business tasks, vision, mission, strategy of the organization? So I think that is where it all starts. As a Rabobank, I can show you later on, we have created a ethical framework for our business. You can derive your business standards and your business ethics from that ethical framework. Then the question, if you say, I have an ethical business, I do business financing, agriculture, then there is the question you need to answer, you want to answer with your AI or your machine learning. And then you can start working with the question. Is the question specific, transparent, and focused on AI, ML? That's one of the things we learned at the schools at BigML. And is it put in business terms? And does the business have a justification for the question? And does it violate the ethic frame? So you see now I come into a cascade. So does the organization have an ethical framework? Yeah, okay, can I do this question within that ethical framework? And the question then needs to be so precise that it also includes the data that will be used in the question, including the proposed data field sources and samples. For that, I can give you an example. If I, as a bank, want to do a mortgage, say, and the business says, hey, yeah, you use gender, ethnicity, you use the age, the zip code, and you use the religious preferences, then everybody in the business would say, no, that's not ethical, Jan. That's not ethical. So if the business says, we want to include gender and thing, but that violates with the business ethical framework that we will not make a difference on social status or gender or ethnicity, then the model never will be created. Huh? So then a colleague of mine said, yeah, but the current status of data science is that they throw in all the data they have and then see what works. So that's the question, that's the practice you should start questioning. And then you can also ask the question, can the question be answered with or without the consent of the user, employee, or customer? Because if you need consent of the user, employee, and customer, you need to know that on beforehand. So the question includes the question, the reference to the ethical framework, and including the data that is used to create a model. Then now I have a chain. Hey, I can now create a model. Do I reuse parts of previous models? Is it designed for dynamic calibrated learning? Is the model so the essence here is that the model can only fulfill the question that's been raised with the data that has been formulated. And every decision is explained by the model. That's why we use BigML, because it explains every decision. And only the data formulated in the question is going to be used for the modeling. And it can be tested then against the ethical framework. the outcome aligned? Is the outcome aligned with the business ethic? I'm going to show you later on. In a few minutes, I'm going to show you how you can do that within BigML. That's a cool pattern I designed. Now, if you have a business that has an ethical constitution, that has an ethical notion, you have a question that is derived within that context of that business, you also impose on the business that they stipulate what data is going to be used and if that data is ethical, yes or no. Then you say the model creation is just creating a model and giving answer to the question based upon data that's being formulated. Then you can go into execution, and then you need to make sure that the model is applied for answering the question and that question only. And then you can ask your ethical questions again. Are personal values, autonomy at stake, permissions from user employee? So if you placed it before that you need consent, you could do human in the loop, end user influence takes action, and you can build in now safeguards, feedback, monitor, data-driven, model competence, performance, ethical performance, decision performance. That's, I think, you can. So you have different stages in your modeling, coming from a business to the question, to the modeling, to the use. And then you have 2 steps left. When the model is obsolete, you need to destruct it because it needs to be removed, because if the question is not relevant anymore, I do not do mortgages anymore, then I need to throw away the model. And if I want to have some parts of the AI left over for reuse, I need to really reconsider if that's valid, yes or no, because the reuse of parts of the model as a total could be very challenging and tempting, but also challenging in an ethical framework. So if I use German text from the 1940s, I will get a different idea on reality than I use Wikipedia of the last 10 years. So you need to be very sure that you want to reuse the model for those purposes. Okay, this is was my thinking. So starting off with the business initiation, question, model creation, model use, and then some segments on destruction and reuse. And then I come into, okay, then I can become ethical. Then I have some frameworks. That's nice. You come in here with the nice philosophers again, Kant and Aristotle, even about rights, responsibilities, results, relationships, reputation. Now I can start thinking on those ethical frameworks from within a more practical, pragmatic way of working and thinking. Then I can do some bias assessment. Now I can say, okay, we do not want to bias on demographics or on ethical and ethnical profiling, etc. And you can now build in those things in your machine learning: race, gender, religion, ethnics, nationality, social class. Okay, now you can look at a thing that is if your steps are correct, then my assumption that an algorithm in itself is not discriminating, but the data points are, and the data you give him holds. So we have a great responsibility because we have a power to just predict anything we want with any data we want, but that power comes with great responsibility and being accountable and responsible. We consider machine learning algorithm as inherently objective. They do not have a bad intent. So a random forest will not say, no, we're going to discriminate on race or on gender. But the data can be. So that's the argument I'm trying to put forward. And all algorithms may reinforce human prejudices. For example, if I use data from 10 years ago from the bank, and there was in Amsterdam an area that you wouldn't lend money to the people who live there, then the algorithm still could think that that is a good thing to do, to reject all the loans from that area. I, as a human, make decisions and I discriminate occasionally, but the algorithms, okay, they learn from the reality we put into the data. So why can predictive models discriminate? Because the labels are wrong. We have historical biased decisions. Stereotypes, economic incentives could be. Data is incomplete, omitted variable bias, leaving out important causal factors. The model compensates for the missing factor by over or underestimating the effect of other factors. We have a sampling bias, all those things we come across also with machine learning and BigML. So sometimes you have models that do not perform or overperform, and then you could have trapped into the sampling bias loophole. But we assume there is no intent to discriminate on the above factors as gender, race, social status, etc. So that's what we assume. We do not want to say you cannot get a loan because you are male, or you are woman, or you are from this ethnical group. That's not the. We assume that we as a company, we as a business, do not have that intent. So how to do that? So if you look at the process that I sketched, so the business intent, the question, the modeling and use, then there should be safeguards in that whole process. So you shouldn't only assess the algorithm, but you should assess the process of getting there. And now is a nice thing. You could now make a pipeline in BigML that gives you the proof that your algorithm and your data is not biased. For example, I created this. Bear with me. To the left side, I see a data without a bias attribute gender. I create an anomaly detector because I like anomaly detectors. Then I score the data set with anomaly score. Then I have the data with an anomaly score. Then I add the gender again, and then I create a data set. I will show it to you just now with an anomaly score and a gender attribute. Then I do a split and train because I want to be sure. Then I build the tree model, and then I assess the test set on the model. And if the algorithm cannot distinguish between male or female, then I do not have a bias. Huh? You agree? So you must agree that if I do this, then I kind of prove. Now I certainly prove that that the score is not influenced by the gender. So let's do it. I, of course, prepared something. So I created a data set. This is a real data set, but with different features, names. It's only for 1 till for 78. And I have a gender, and those genders is a 1 or a 2. I hope you can see this, or perhaps I can enlarge it a little bit. So I have some features. I have, of course, my numeric features that range from something to something. I have some buckets. I have all things. So what I did, I started off with this data set, and for to be sure, I made the gender the target, and this field is not preferred. What I did then, I create an anomaly detector. I make sure that gender is not in the set to be used by the anomaly detector. Then I get the anomaly. I get some anomalies, of course, because this is a real world data set. I get some anomalies. Everything above 60% is anomalous. Cool. So you see the forest back here, and okay, this is just the work. Then I made a batch anomaly score. So I place the anomaly score back into the data set. So that's what I did. So this is what I prepared for you just half an hour ago. Now I have a data set with two things important in there: a score and a gender. So I will filter this data set. I throw everything away, so exclude all fields, and I just include gender and score. Those are the two fields I want to assess, because this is a real data set, so it's a little large. So it's 220,000 rows. I need so this is real life. So could go wrong. Could go wrong. So I now have a data set, and I have a score, and I have a gender. The score comes from scoring the data set, and now I want to predict the gender based upon the score. See if that is possible. If that is possible, then I have a biased data set. I have a biased model. So I make a training and test set. So I want to make sure that I have a good set to test it against. So this is the 80%. Now I'm going to make a model. I'm going to make a tree model for you. Create a model, gender as the target, and then see what it comes up with. It comes up with a fancy tree with all kind of cutoffs. This already says something to me. It's such a complex that he cannot really, and now I want to evaluate it. And remember, if I evaluate it, the better it can distinguish male and female, the better it will be able. This is, so I get a phi score of 0.006. So it really hasn't a clue. If you look at the ROC curve, it's almost flat. So it cannot decide. It really cannot decide whether it's a male or female based upon the score it got. So where does it bring me? It brings me that I can find that I can have a workflow in my BigML environment by which I can determine if I leave out the discriminating items and later place it again, and then see if the model can distinguish between those discriminating factors, and the phi is less than let's say 0.2, then it's if it's above 0.2, I really need to consider that my model is biased towards the discriminating factor. So this way you can make a discriminating aware solution where you can maximize accuracy and minimize discrimination. And remove the sensitive attributes, perhaps you will have to, because it's not always true that only the gender field will indicate the gender for you. It can also be the web shops I use or the shops I use my debit card on. So it's not, so you will find in this way, you can also find the features that will do the discrimination without the discriminating factor being into your data set. And this is what I'm almost ending my little journey with you. So AI is innovation, system thinking, and reflection. So we need to learn from what we are doing. It's not that we only do these things to comply to regulations like Toyota does in this example. Is that we do not have a general, we do not have an overall big standard. No, we need all these things we do, and we talked about that in the panel discussion just before too. That this is a learning point of view. We need to experiment and see how we can benefit business. And this, in the ethical and trustworthy framework, we need to assess the question that the business asks us with the data they give us to work with. And if we do that, I think we can come to a trustworthy AI. And I think this is the way you should experiment with your data. Leave out a discriminating attribute, do the modeling, and see if with the model result you can distinguish between the gender attributes. I wanted to show you one more thing. For example, this is what we created with Rabobank from a CLR, so compliance, legal, and risk perspective. Let's say our ethical compass for AI. And we couple that to the ecosystem of the CRISP framework. So we really want that ethical aspect to be part of our practical work. And BigML isn't part of that.